Radar just found a structure buried under a mile of ice, not a rock formation, not a natural fracture in the bedrock, a shape, straight edges, right angles, something that should not exist 2,000 meters beneath one of the most hostile, unreachable places on Earth. For decades, scientists have been flying instruments over Antarctica, bouncing radio waves through the ice sheet to map what lies underneath. Most of the time, the readings show exactly what you would expect: rock, sediment, the slow grinding history of a continent that has been frozen for millions of years. But every so often, the data throws back something that does not fit, a pattern too clean, a structure too symmetrical, and when that happens, researchers stop scrolling and start staring. This is one of those moments, and by the end of this video, you are going to understand exactly why a single radar pass over the Antarctic ice sheet has quietly become one of the most talked about anomalies in modern exploration. Think about that for a second. A mile of solid ice sitting on top of it. No sunlight has touched that spot in longer than modern humans have existed. No footprint, no shovel, no drill has ever come close to disturbing it. And yet here we are, looking at a shape that, by every normal geological expectation, simply should not be there. Let's start with how something like this even gets found in the first place, because the method matters just as much as the discovery. Antarctica is not just covered in ice, it is buried under it. In some places, the ice sheet is over 4 kilometers thick, meaning the actual ground, the rock and soil that make up the continent, has not seen open sky in millions of years. You cannot dig through that. You cannot drill through it fast enough to survey a continent. So scientists use something else, ice-penetrating radar. The concept is simple enough to explain in one sentence. A plane flies low over the ice, sending radio waves straight down. Ice is mostly transparent to these waves, so the signal punches through the frozen layer, hits whatever is underneath, and bounces back up to a receiver. By timing how long that return trip takes, and by reading the shape of the echo, scientists can build a picture of what is hiding beneath the ice without ever touching it. This is how we mapped subglacial lakes, hidden canyons deeper than the Grand Canyon, and mountain ranges that have never been touched by human hands. It is one of the great quiet triumphs of modern geophysics, and it is also how this particular anomaly first showed up on a screen. The planes that carry this equipment fly for hours at a time in brutal cold, tracing long straight lines back and forth across the ice sheet in a pattern that looks almost like mowing an enormous white lawn. Each pass generates a strip of data, and researchers back at their labs spend months afterward combing through it layer by layer, looking for anything that breaks the pattern of ordinary bedrock. Most of the time, nothing does. The vast majority of a survey like this is frankly uneventful. Rock is rock. That is exactly why the passes that do produce something strange stand out so sharply against everything else in the data set. It is also worth understanding just how much area we are talking about. Antarctica is larger than the United States and Mexico combined, and only a tiny fraction of its hidden bedrock has ever been mapped in detail. Every new survey is essentially exploring uncharted territory, just underneath a layer of ice instead of underneath the ocean. So when something unusual turns up, it is not being compared against some other complete map. It is one of the first clear looks anyone has ever had at that particular patch of ground. According to survey data collected during one of the long-running airborne radar campaigns over East Antarctica, a section of bedrock roughly 1.5 kilometers below the surface returned a signal that immediately stood out from the surrounding terrain. Natural rock formations tend to look chaotic under radar, cracked, uneven. shaped by millions of years of pressure, erosion, and shifting ice above them. This was different. The echo showed a series of long, straight lines intersecting at consistent angles. Not one line, not two. A pattern that repeated across a wide section of the survey path, almost like a grid. Researchers who reviewed the imaging described it as looking less like geology and more like architecture. Now, before you picture ancient ruins and buried cities, it is worth being honest about what scientists actually do when something like this appears. They do not immediately shout ancient civilization. They start ruling things out, one explanation at a time, the same way any good investigation works. The first explanation is always the boring one, because the boring one is usually correct. Could this be a natural rock formation that simply fractured in a geometric pattern? It happens. Certain types of bedrock, especially ones with consistent mineral layering, can crack along surprisingly straight, repeating lines when placed under the kind of pressure an ice sheet exerts over millions of years. Basalt columns are a famous example of nature producing shapes so regular they look artificial, even though there is nothing artificial about them at all. The second explanation is a data artifact. Radar imaging is not perfect. Ice has internal layers, air pockets, and density variations that can distort a signal on its way down and its way back up. Sometimes what looks like a structure is actually the radar picking up interference from the ice itself, layered like sedimentary rock, creating false patterns that look ordered but are not. The third explanation, and the one that keeps this particular case interesting, is that this section of the survey does not cleanly match either of those categories. When researchers compared the anomaly to known fracture patterns and known radar artifacts from other parts of the ice sheet, it did not line up. The angles were too consistent. The spacing between the lines was too regular. Whatever this is, it behaves differently from the noise scientists are used to filtering out. That is the part that turned a routine data review into a genuine talking point in glaciology and geophysics circles. Not because anyone has proof of what it is, but because nobody can yet confidently say what it isn't. If you are enjoying this so far, go ahead and hit that like button right now, because it genuinely helps this video reach more people who are into stories like this. And if you have not subscribed yet, now is a great time, because we are about to get into the theories, and this is where things get a lot more interesting. So let's talk about what this structure could actually be, starting with the most grounded possibilities and working our way out to the ones that sound like science fiction, but are still taken seriously enough to be discussed in research circles. Option 1, a hidden meteorite impact structure. Antarctica has been struck by objects from space before, and the ice sheet is actually one of the best places on Earth to search for meteorite fragments, because dark space rock stands out sharply against a white background. A large ancient impact could leave behind a crater with surprisingly regular ring-like fracture patterns in the surrounding bedrock, especially if the impact happened millions of years before the ice sheet formed and the site was preserved rather than eroded away. Some researchers who have looked at similar anomalies elsewhere on the continent, including a mysterious mass concentration detected in the Wilkes Land region years ago, have pointed to impact geology as the most likely natural explanation. It is possible this new anomaly belongs to the same family of buried craters. Option 2, subglacial volcanic activity. Antarctica sits on top of an active volcanic system in several regions, and volcanic rock can cool into strikingly geometric formations. When lava cools slowly and evenly, it can crack into repeating polygonal columns, similar to famous surface formations like the Giant's Causeway. If there was once a lava flow in this region before the ice sheet buried it, a similarly structured formation could be hiding beneath the surface right now, and radar could easily interpret those consistent angles as something built rather than something formed. There's also a variation on this theory worth mentioning. Rather than a single lava flow, some subglacial regions of Antarctica sit above ancient rift zones, places where the crust itself is slowly pulling apart. Rift zones can produce long, straight fault lines running for kilometers in remarkably consistent directions, sometimes crossing each other at near-perfect angles as the crust fractures under tension. If this anomaly sits along one of these hidden rift systems, the grid-like pattern researchers are seeing could be a direct signature of tectonic stress rather than anything volcanic or artificial at all. It is a purely geological answer, but it is also one that would still make this a genuinely rare and fascinating find, since so few subglacial rift structures have ever been mapped this clearly. Option 3, and this is where the conversation gets a lot more speculative. Some researchers and independent analysts have floated the idea that the pattern could represent the remains of an ancient structure from a time when this part of Antarctica may not have been covered in ice at all. This theory leans on the fact that Antarctica's climate has not always looked the way it does today. Millions of years ago, before the ice sheets formed, parts of the continent had a much milder climate, with evidence of ancient forests and river systems found in geological surveys. The idea that something could have been built there before the ice took over is, to put it mildly, an extraordinary claim, and it would require extraordinary evidence to support it. Right now, that evidence does not exist. What exists is a radar echo with a shape scientists cannot yet explain. It is important to slow down here and be honest about where the actual science stands. No excavation has taken place. No physical sample has been recovered from this specific site. Everything we are discussing so far comes from remote radar imaging, which is an incredibly powerful tool, but one that has limits. Radar can tell you that something down there has an unusual shape. It cannot tell you what that something is made of, how old it is, or how it got there. That requires either drilling, which is extremely difficult and expensive in ice this deep, or waiting for future survey passes that might capture the site with even sharper resolution. This is exactly why the story has not gone away. It sits in that rare, uncomfortable space between explainable and unexplainable. Scientists are not calling it artificial, but they are not confidently calling it natural either. And in a field built on caution and peer review, that kind of open-ended uncertainty is unusual enough to make people pay attention. There is also a practical reason nobody has simply gone and checked. Drilling through more than a mile of Antarctic ice is not a weekend project. It requires specialized equipment, a dedicated research team, months of logistical planning, and a budget that has to compete with dozens of other approved scientific priorities. Past deep ice core drilling projects, the kind used to study ancient climate records trapped in the ice itself, have taken multiple field seasons just to reach depths similar to where this anomaly sits. Even if a research team decided tomorrow that this site deserved a direct investigation, actually getting a drill bit down to it could realistically take years of preparation. That gap between what radar can show us and what a physical sample could confirm is exactly where mysteries like this one are able to live and grow for so long. There is also a broader context worth understanding, because this is not the first time Antarctica has produced a radar mystery like this. Subglacial lakes were once considered nearly impossible, until radar confirmed dozens of them hidden under the ice, some the size of small countries, some potentially isolated from the surface for millions of years, sealed away in complete darkness with their own unique ecosystems still being studied today. A hidden mountain range called the Gamburtsev Mountains was mapped entirely through radar, revealing peaks as tall as the Alps that no human eye has ever directly seen. And that earlier gravitational anomaly in Wilkes Land, the one many scientists now attribute to an ancient impact crater, was originally treated with the same mixture of caution and fascination this new structure is receiving now. In other words, Antarctica has a track record of hiding things that sound impossible right up until the data forces researchers to take them seriously. That history is exactly why this new anomaly is not being dismissed outright, even by scientists who lean heavily toward the natural explanations. The continent has earned the benefit of the doubt. Consider Lake Vostok, one of the largest subglacial lakes ever discovered, sealed beneath roughly 4 kilometers of ice, for what researchers estimate could be millions of years. When it was first confirmed, the idea of a massive liquid lake surviving that long in complete isolation under that much pressure sounded almost too strange to be real. Today, it is one of the most studied subglacial environments on the planet, and scientists have even discussed the possibility that microbial life could exist there, cut off from the rest of Earth's biosphere for an almost unimaginable stretch of time. If a hidden lake that size can go undetected until radar finally reveals it, it becomes a lot easier to understand why a hidden structure, natural or otherwise, could remain completely unknown until the exact same kind of survey stumbles across it. So where does that leave us right now, in this exact moment? We have a radar echo showing straight, repeating, geometrically consistent lines beneath roughly 1.5 miles of Antarctic ice. We have 3 serious categories of explanation on the table, ranging from a fractured natural rock formation to a buried volcanic structure to a far more speculative and currently unsupported idea involving something built before the ice sheet ever formed. We have no physical sample, no excavation, and no confirmed identification. What we have is a genuine open question sitting in the hands of researchers who are actively working to figure out which explanation the evidence eventually supports. That is honestly the most exciting kind of story there is. Not a neatly wrapped answer, but a real mystery. Sitting under real ice, being investigated by real scientists using real data. No exaggeration required because the plain facts are already strange enough to hold your attention on their own. Future survey missions, along with potentially deeper ice core drilling in the region, may eventually settle this one way or another. When new data comes in, whichever direction it points, this is exactly the kind of story worth coming back to. Antarctica has surprised researchers before, and given everything we have just gone through, there's a very real chance it is about to do it again. Before you go, if this kind of deep dive into unexplained discoveries and hidden mysteries is something you enjoy, subscribe to the channel and turn on notifications, because stories like this one get covered here regularly, often before they make it into mainstream coverage. Drop a comment down below with what you think this structure actually is, because the theories in the comments on videos like this are honestly sometimes as interesting as the story itself. And if you found this genuinely engaging, share it with someone who would appreciate a good mystery, because that is what keeps channels like this one able to keep digging into stories the rest of the internet has not caught up to yet. Thanks for watching all the way through. This is far from the last unexplained discovery buried in the ice, and And when the next one surfaces, you will be the first to know. Antarctica keeps its secrets well. It always has. But every year, a little more radar data comes back, a little more of that hidden bedrock gets mapped, and a little more of the picture fills in. Somewhere in that growing data set is the answer to what is really sitting beneath a mile of ice in this exact location. We just have not found it yet, and honestly, that is what makes this worth paying attention to.